Welcome back, everyone. My name is Dan Vega, Spring Developer Advocate at VMware. Today, we're going to be talking about Spring Boot 3.2. I've been doing that a lot lately with good reason. It just was recently released. And today, we're going to be talking about one of the major themes that were in Spring Boot 3.0 and beyond, and that's runtime efficiency. It started out in 3.0 with support for AOT, or ahead of time compilation, and this is a precondition for building native images with something like raw VM. In 3.2, we're adding two new features. One is virtual threads. I'll have another video on that. Today, we're talking about Project CRaC, which stands for Coordinated Restore at Checkpoint. And it comes back to this idea that all the workloads that we're building for production, there are different use cases for different workloads, right? In this case, we're talking about faster startup time without compromising some of the things we may do with something like ahead of time compilation. So I don't invite a lot of guests on this channel, not because I don't like spending time with others, just because it's kind of been my YouTube channel and it's just been me talking to you guys. But today is a different day. I'm really excited. I'm bringing on a guest that if you watch any of my other content or Spring Office Hours, the podcast I'm a part of, then you will undoubtedly be aware of Deshawn Carter. And so with that, I'm going to introduce Deshawn, and we're going to go into talking about CRaC, why you might want to use it, a little bit of a high-level overview of what it is, and then we'll show you a real-world example of some of the benefits you can get by taking advantage of this. So with that, let's bring on Deshawn. All right, I'm here with the star of the Spring Office Hours podcast, Deshawn Carter, who's also a fellow Spring Developer Advocate, and more importantly, my good friend. Deshawn, how are you doing today?
I'm wonderful. And we are friends. Like our kids have hung out. Like we've been traveling together. We've done some fun things there. We've ran in interesting places, and
we have run in interesting places. We've ended up in interesting places.
Yes.
So yes, we are good friends, and today we're going to have some fun. We are going to talk about actually before the one person in my audience here on YouTube who may not know you. Well, what is your name? What do you do? Can you tell us a little bit about yourself?
My name is Deshawn. I am a Spring Developer Advocate. I've got kids, a beautiful wife, and I coach basketball and football and soccer and maybe a little track here soon. I'm a Raspberry Pi enthusiast. I love putting Spring Boot on small devices, on edge devices, and those kinds of use cases. And and I'm trying to stay active. Ran the Philadelphia Marathon a couple weeks ago. And I'm just deliberately practicing to build, run, and manage better software faster. That's my tag.
You have 4 kids. You're in all these activities. You do all this stuff in the Spring and Java community. Where do you find time for all of this, sir? I have 2 kids, and I'm like, I have no time for anything.
It's a team effort. My oldest is second mom. My wife does most of the logistics.
Yeah.
She's also CEO and CFO of the house. So
Nice. Cool. All right. Well, today, so I've been, Spring Boot 3.2 was recently released. We've been talking a lot about it a lot. We talked about it on Spring Office Hours, so I'll leave a link in the description to that show as well. That was kind of a high-level overview. We've been diving a little bit deeper into some of these things. I have a video on virtual threads coming out, so I'll put that in the description below. But today we're going to talk about CRaC. And that stands for Coordinated Restore at Checkpoint. And I think what's interesting about this is the theme that's been going on in Spring Boot 3 has lent itself to runtime efficiency. So we started out in Spring Boot 3.0 with AOT. We're coming up here in 3.2 with virtual thread support from JDK 21, and now initial support for Project CRaC. And you and I talk about this all the time. I think one of the things that I love about this is that Java has an answer for every kind of workload that you're trying to put into production.
Yeah, Java's been around. Every year's the year Java's dead, but it's still here. It's still moving forward, and it keeps on getting better, right? Being a Java fan, I'm always faced with, you should use this language for that. We've been on fun Twitter threads. Oh, no, you should definitely use this language for that.
Yeah.
And and there's an answer. And now it's going to take some evangelism, right? We're going to have to share how it works, and we're going to have to teach people like there is a solution here, and it just keeps on getting better.
Yeah, so I'm excited. We're going to talk about CRaC today, Project CRaC, and kind of just what it is. And again, just another option for runtime efficiency. So what we're going to do is jump into a screen share here. We're just going to talk about what CRaC is at a high level, and then we'll show you a demo, and hopefully that kind of puts it into perspective and makes it a little bit more real. Because I think even before, Deshawn and I kind of did a dry run of this yesterday. And before that, it was like, okay, I understand what it is, but until you see it in action, like you can't really truly appreciate it. So I'm here on the documentation for Azul. And again, then one of the reasons I invited Deshawn on, Deshawn is really knowledgeable in all things Spring, but particularly when we start talking about runtime efficiency, AOT, virtual threads, CRaC, we get into some Docker container stuff today, containerization, Docker. Deshawn knows everything when it comes to that stuff. So I would like your we're looking at the docs. I would like your kind of like overall thought on what Project CRaC is going to help with here in both the Java world and the Spring world.
So I'm gonna go back in time a little bit. It was around 2014, 2015. Different languages were kind of popping up for this microservice architectures. Which should we use? Oh, you got to use this. And there was a lot of, kind of competition in the space. What does coordinated restore at checkpoint? What does that do for us in the competition, in the landscape, all the different languages, all the different options that we have? One of the, I guess, pain points, one of the things that other languages could poke at was Java's too slow. And what they were often talking about was just the startup time. Java's too slow. And we know that the JVM is amazing. JVM's fast, does amazing things. But that startup time was kind of a pain in our side for a while. So one of the things that this coordinated restore at checkpoint answers is that startup time, but it doesn't give anything else away. All the other benefits that we get from Java, all the other benefits that we get from the JVM are all there. So it addresses that startup time, and it makes it, really easy to consume. So we have a nice new way of addressing this startup time issue, and it starts up comparable with any other language better than most.
Yeah, so I think one of the things you mentioned there was, Java is really good at certain things. And one of those things is, hey, once it starts up and takes, if it's a long running request, if it's a long high throughput application, the JVMs are great because it as soon as it starts up, now it starts to make some optimizations, right? It does things like, hey, looks at code and says, hey, this is being called a lot. I'm going to optimize it. I'm going to compile this down further and get some optimizations out of there. And so this is great. Like you said, the only pain point of that is the actual startup time, but that doesn't affect every workload. But some workloads it does. So if we need to do things like scale to zero, or we just have a request that needs to come up and take a request and then go away and come back at a later time, then this is where this stuff becomes very important. As you said, there are answers for it outside of Java. And now I really appreciate that like Java has an answer for everything. So the documentation, if you go through here, you can find a little bit more about what checkpoint restore is. Really, Deshawn did a great job of kind of summing up there. The startup improvements, the things that you kind of just mentioned, that's what's really going to kind of catch everybody's attention, right? So here's an example in here: time to first operation. You'll see the OpenJDK. There's a sample application here, almost 4 seconds on Spring Boot. OpenJDK on CRaC. 38 milliseconds. That is crazy. And that's just like one invocation, right? Like what if we're doing this 1,000 times, 1,000,000 times, depending on scale?
We're paying per millisecond now, right? In the
that's
cloud,
a lot of
those
money.
Milliseconds matter.
Yeah. So that is the big thing. And then there's some more information here. A really good walkthrough by Garrett, who's a developer advocate on the Azul team. And there's also a really good article that he wrote that I will share in the description below as well. So I guess that's another good point to kind of point out. So we're looking at the Azul docs, but this is not an Azul specific technology, right? This is from the OpenGDK world.
Yep. Framework made available. It started, it became available, a possibility because of changes in the Linux kernel. So good point to kind of point out that this is something that can only be done on a Linux kernel with the features that it provides. And yeah, and it's a framework. It's a specification that can be adopted by others.
Cool. So I think the best way to kind of show this off is we are going to use a project today, the infamous Spring Pet Clinic. I have cloned that onto my machine. We'll take a look at that application. And then thanks to a repo from a fellow core worker of ours on the Spring team, all around genius. I think I'll kind of leave it at that. But Sebastian Deleuze has a really nice GitHub repository out here that shows this. The reason for this is, as Deshawn mentioned, you can, if you're on a Linux machine, you can bypass everything we're about to tell you, because if you're on a Linux machine, you have Creo available. You can actually do this checkpoint restore right on your own machine. If you don't have Linux available, you need to run it in a container. And this is the repository that really showed me the way to be able to do this, is going through some of this stuff and understanding how Sebastian built a container to run this demo on. So I guess the other important thing is, Deshawn, as a developer just writing code, I don't know that I need to really worry about this, right? This is more, hey, let's work with our platform teams. Let's work with DevOps and say, hey, we're having some initial problems starting our application up. I have a solution for you. This is something we need to work together on. But as far as writing code, I'm not writing anything different, right?
Right. So as a developer, as a Java Spring developer, people are going to say, hey, yeah, no, it's not going to start up fast enough. This is your solution. Hey, just use Azul and Project CRaC, what it makes available, and let that run on the platform. It'll start up fast enough. We won't lose any milliseconds. It won't translate into big dollars. So here's my code. It's my same Java code, my same Spring code. Spring makes it easy. Spring puts those hooks in place. Now with 3.2, we've got hooks in place to make it even easier so your application can start up quickly, have all the information that it needs in order to do this runtime. One of the other things that it's on my mind, it doesn't really get talked about a lot, is you mentioned how the JVM, it optimizes as it runs, right? In our kind of path to production, you've had these soak testing, like, oh, let's run a bunch of things and let the JVM optimize for a while. You could also take a checkpoint after your JVM has had time to optimize. You could take another checkpoint so that when you start up, not only is your database connections there, all of your classes are in place, but your JVM has been optimized. So you get that optim performance for all the work that goes after that.
Yep, that is a good thing to mention. Like, so as a developer, there isn't really anything different, but there are hooks into this API. So if there are things that you need to do, there are hooks into it. And I think even Garrett's article mentioned this. Like, if you're not on Linux, there is another package, a dependency that you can pull in to write code against those hooks if you're not on Linux. So yes, I would say check out the article, check out the documentation for Azul. Mainly what we're doing today is talking about this at a high level, and we're just going to look at some results. We're going to run this Spring Pet Clinic application that you can download yourself, see how long it takes, and then we'll take a look at the optimization made by CRaC. All right, so here we are in the IDE. We're taking a look at Spring Pet Clinic. What I really love about this application is, we use it all over in the Spring ecosystem, but it's constantly being updated. So this is running the latest and greatest Spring Boot 3.2. So if I come up here, I can see we are on 3.2. It's taking advantage of the new Docker Compose module in 3.1. So, hey, you don't got to go in and set up these services to go ahead and run this example. Deshawn and I talk about it a lot. Git, clone, run. Like, I just want to download this repo and run it. I don't want to have to configure everything. You can do that with Spring Pet Clinic. So I'm going to go in and just do a little example here. So let's say mvnw, let's just run a clean package. Now, I know we can run this from the IDE, but I want to do kind of an apples-apples comparison. I want to produce an artifact, which is, in this case, a jar. And I want to go ahead and run that jar and see what that startup time is. So we'll see. We'll wait for this. You can see it's going through all of the things that it needs to do as far as the Docker Compose stuff. It's starting up any like containers for dependencies that it needs. Has a database connection to, it looks like MySQL there. So it'll run the tests, and then once we have our artifact, we can go ahead and run it. Okay, so what did that do for us, Deshawn? We should have something in our target folder, right?
Yep.
We get this weird, there we go. So we have a Spring Pet Clinic jar.
Yep.
So I'm going to go ahead and just say java-jar, target. Oh, whoops, I can just
You know what might be a better idea?
Hmm.
It might be a better idea to do the build pack and have it running in a container, so that then you got an apples to apples as a container.
Yes,
versus...
and I believe we tried that yesterday, and I had an issue with the build one, not the checkpoint one.
Yeah, just do a
we'll see. Let me
Spring Boot build image.
Yeah, let's run this, and then I'll do that. I'm just showing what a normal like jar would run. Yep. So we could see this is almost 5 seconds.
Almost 5 seconds.
Almost 5 seconds. Again, I think in the grand scheme of things, not a huge, not a big deal, because once it's up and running, it can handle the throughput, the optimizations are going. But if this were a deal breaker for you and said, hey, we need to like be able to spawn new instances immediately, and this 5 seconds is too much, I get it. For certain workloads, that may be the case. We have an answer for that now. So let's take a look at that. So again, going through Sebastian's GitHub repository, we were kind of able to piece together how to create this container that we can run this example on. Again, if you're on Linux, you can do this without creating the container, and it's a little bit easier of a demo to kind of digest, right? What we got to do is we're going to create a few scripts, and one thing I will say, you want to make sure that you change the file execution, make sure that it's an executable file, because we ran into that issue before. So make sure each of these files that you create, you can go ahead and execute. So I start with this checkpoint.sh, and this is where I brought in Deshawn, because Deshawn can help us make sense of some of these scripts. So what are we doing here in this particular script?
So this script is what's going to run right inside of your project's directory. What it's doing, it's determining which platform it's on, ARM64 or AMD 64 or x86, because this capability, another good point, the image that we make, the image that we use, that snapshot that we take can only be restored on the same platform, the same architecture and operating system. Mm-hmm. So this is making that distinction so that we have the right JVM for the platform.
And that's a good point. What is this? I'm looking at this Zulu CRaC JDK. So this is a special JDK, right?
Azul has a special place in my history, because Azul was the first JVM that kind of broke the barrier on heap, right? They were doing advanced things with the JVM that I never even could comprehend the need for the things that they were doing for the ecosystem. But it was one of the first Java user groups in the area that really like kind of stuck home with me. So yeah, they're in the ecosystem. They're doing amazing things. And this is just another example. It's their JVM. One of the things that I've been saying a lot lately is JVMs are one size fits most, not one size fits all. You're going to run into some edge cases where maybe the JVM that the default isn't going to work for you. And again, this is why Azul has been around, because they were solving problems for the ecosystem that maybe your regular, your default JDK wasn't able to solve. So this is another great case. You want to solve that startup case? Here's an option.
Yeah, and I that's a great point, because I always used to like open up SDK Man, right? And it's like SDK list Java, and there's 15 different vendors. It's like, why should I care about 15 different vendors? And like you're saying, there might be some edge cases where a particular vendor like Azul has a JDK that will solve a problem for you.
Yes, it's a and I think different JDKs have different strengths, and it's worth exploring.
Yep.
Right. Or if you run into a problem, it's worth taking a look at another JVM to see if you can solve it that way. But It's always worth asking, raising your hand, because we have a great ecosystem, a great community.
For sure. All right, cool. So we pulled down the right JDK for the job. echoes out using CRaC enabled JDK. Then we run MVM clean package that
Just
is
like we
cleaning out the target directory as we just did and creating that jar file. Now, what are we doing here on line 12 with Docker?
The next command is simply just build a Docker image. So it's got a Docker file, and I like to say friends don't let friends use Docker file. But in this case, we're going to make an exception.
Yep.
We're going to build a Docker file, and then that Docker file is going to do the build, and it's going to do some additional things. So we can open that Docker file.
This is the Docker file.
That's
So
the Docker
this is
file.
the Docker file that we are going to use.
This is a pattern. This is the specification for creating a Docker image, an OCI compliant image. And it's got the instructions. Hey, here's our base operating system. We're setting some environment variables. We're setting some paths, etc. But inside of that image, we're running some commands. We're getting because we use Ubuntu, we're getting a Linux kernel, and we're doing these things on a Linux kernel inside of this image. So that's what we're doing. We're copying that jar file into that image, and then we're setting the entry point. How do you want to start that image?
So the entry point is this script in source scripts entry point. And then this does a couple things, right?
So part of the specification of a Docker file is how do you want to start it? So you've got an image, you run that image. What are the instructions? What do you want me to do then? Just start up? No, you give it a entry point. You give it a starting point, or a command is another option. And this is going to, do all the steps that it needs. The interesting part here is it's looking for this CRaC files directory. It's
what
looking
is that?
for that mount. So what's happening, what this coordinated restore checkpoint is doing is your JVM starts up. The JVM, all the status, all the connections, all the information that's held within that JVM is taking a snapshot. That hopefully that term makes sense. It's taking a snapshot, a copy of everything that's there, and it's writing it down to a disk. So this is a check. It's going to do a check. Does that already exist? Or do I need to make room for another? Do I need to create that directory in order to make this snapshot? So
and it's doing a snapshot after that kind of climb, right? So the slow part is that climb. Once we get to like peak performance, it's going to take the snapshot there. So it cuts out all of that kind of slow startup time.
Well, we showed two flags here. So we passed in the -R flag. This uses one of the new features that came with Spring Boot 3.2. This Spring.context checkpoint on refresh. So it's a hook delivered by Spring that says, now I'm ready for you to take that snapshot.
Nice.
The other option, without the -R flag, the way that we were doing it before Spring Boot 3.2 is we wait some amount of time. There's a sleep 5, like wait some amount of time, 5 seconds in this case, and then take the snapshot.
Cool. So it's going to take a snapshot. That means the next time that we start up, then it can go ahead and read from that snapshot instead of doing the slow startup time again.
Yep.
Cool. So I think with that, we can go into our checkpoint.sh here, run this. It should create a Docker file for us, right?
Yep.
And then it commits this. So what does line 16 do? I know we talked about this yesterday, but we create this Docker file, we run it, and then what?
And then it's waiting 10 seconds, and then it's going to give us this alternative option. We're going to have this other checkpoint image. So it's got an image, it's taking a checkpoint. Hey, it understands that there's a mount. After 10 seconds, you should have, because in the other command we waited 5. After 10 seconds, you should have a new image that is ready.
So we'll end up with 2 images.
Yep.
One that is just the normal container that will start up slow. The one with the checkpoint is, hey, it's going to restore from that checkpoint file. This one should start up much faster.
Correct.
All right, so let's do this. I'm going to try and run this checkpoint.sh. And again, this is something we're doing for a demo. This is not something you as a developer is going to do in your inner loop here. This is something that kind of our platform teams would help us with. But we just want to be able to see it. And to do it on a Mac, we have to run this in a container. So this is why we're kind of jumping through these hoops to show this off for you. So it's going to do a whole bunch of things. And I think through the magic of video editing, we will make sure you don't have to wait for it.
Yeah, it's running all the tests. It's doing all the steps. One of the benefits that we could do, one of the things that we can show is with the test containers framework, we can actually validate that that checkpoint image still passes all the tests. So we could actually build this image, do our things, and then use that image as a test container and roll all of our tests against it to validate. Just like we do our JVM. When we do Maven clean test, validate my tests, we could build that image and then run those exact same tests, some set of those tests against that running image.
Awesome. Now, we ran into this issue yesterday, and I think this is because I might have like deleted some stuff and put it back. So if you run into an issue like this, it may be because of permissions. So you may want to say, hey, make sure this is executable and source, what is it? Not main, source scripts, entry point. So I will go ahead and run this again and again through the power of video editing. Make sure you don't have to watch that. All right, so now that finished, again, that was a permission issue. So now I should have some Docker files here, right, Deshawn? So I want to go in and Docker PS. Nope, nothing's running. That's good. We want to see what Docker images are there. And so now, as you said, I should have one that is a builder and one is that our checkpoint. So I think we have...
So there was a restore.
Yep. So we also have a restore file here, and this is going to basically run our Docker file. So it's going to say, hey, Docker run, what is this cap add?
Oh, these are capabilities. So in order to do the steps that the Linux system has provided, we have to give our running Docker instance a little bit more permissions, a couple more capabilities in order to do that.
So we're adding some capabilities. We're running it. We're mapping port 8080 to port 8080. We're giving it a name of Spring Boot CRaC demo. We want to go ahead and change this to the one that is there. So this is Spring Pet Clinic CRaC, and then we want to run the builder first, right? We want to see what this is.
Nope.
Or no?
We want to
we're just going to run
the checkpoint.
We're just going to run checkpoint. All right, checkpoint. And let's see what this provides. Whoa. I didn't even have to wait.
We're done. So the cool thing is we didn't see all of the normal like Spring Boot 3.0 or 3.2.0. We didn't see all that because that was already done. That was done before we took the snapshot. So those logs have already passed.
Right.
And we're starting up in 0.409 seconds.
Wow. So almost 5 seconds to 40 milliseconds.
Yeah.
That's crazy.
It is crazy. And the thing is, depending on your workload, depending on what you're doing, I've many times where I've done demos where I put CRaC and this JVM next to Graal VM and a native image. And many times, the Project CRaC Azul example will start up actually faster than the native image, which is mind-blowing.
Yeah, and that's probably something we could talk about another time. But so we have AOT, we have native images. You and I both love the native image support in Spring Boot 3. We've done some really cool examples with it, but there are differences between AOT and CRaC. Mm-hmm. So yeah, there are some differences. But as you said, one of the big differences for me is with this, you're not losing all those dynamic capabilities at runtime. You can still do things like reflection and serialization and proxies and resources. Yeah,
update properties, attach agents, all the good things. We didn't lose anything from the JVM. We didn't lose anything. Yeah,
but as you said, different workloads, right? Like you and I do a lot of demos where we're building out CLIs for our own machines, like developer tools. That I'm using AOT for. I'm building a native image natively for my machine. So again, right tool for the right job. This is just another kind of tool in your tool belt, if you will.
Yeah. Now, there are some concerns, right? We talked about it's got to run on the same platform. Like we're both running on a Mac Silicon. So we can't take that workload. Even though we built it here and we used Linux kernel, we can't take that workload and run it on an x86 virtual machine or Kubernetes cluster. So that's one concern we have to make sure we point out. The other thing is, if I've got database credentials in my stack in that snapshot, I don't really want to put that snapshot into a registry, right? Don't put all of that that checkpoint. Don't put that into a registry because it's got that information, and because it's a JVM, it's easy to get at that information, right? Mm-hmm. So we want to make sure to think about that. Your platform should take care of that. And because Spring provides those hooks, maybe a little bird told me there's going to be platform capabilities real soon that are going to allow you to take advantage of these things without much effort.
Cool. And I guess one of the other exciting things for me is at least everybody internally or externally, like everything I keep reading as far as support for CRaC in spring says initial support for CRaC. I keep reading that everywhere. This is really just the start of the story, and I expect this to only get better.
Yeah, we had initial support. We supported it, before, but now it's those hooks that we've introduced, and we're going to learn more, right? So it's a two-way street. We need to get feedback from the community.
Yeah, for
and
sure.
We would love to hear your use cases and how it's going and what you're running into. Because let's make sure that we get this project and the spring support. Let's make sure we get it on the right track. We'd love your feedback.
Yeah, cool. I think that's a good place to end it. As Deshawn said, please let us know what you think of this. If you guys are going to take advantage of this in production, we'd love to hear from you. Deshawn, I just want to thank you for coming on my YouTube channel. I know we are together on YouTube all the time, but this is my channel. So I appreciate you taking the time to come explain some of this. I feel like I've learned a lot this week, and that if we can learn something every week, then we're doing something right. So
that's the goal.
Cool. All right.
Thanks so much for having me.
Yeah, no, I appreciate it. And then, as I said at the beginning, Deshawn is the star of Spring Office Hours. So springofficehours.io, go ahead and check us out every Tuesday-ish. Next week's different, but every Tuesday-ish, 3:30 Eastern. We are live on YouTube talking about all things spring. So bring your questions and see if you can't come learn something with us.